Yes, dear friends, the another important analytical instrumental method of analysis is HPLC, high performance liquid chromatography. Yes, it is an advanced chromatographic technique. In ordinary chromatography, which you studied in your lower classes, was you will be having a great burette like instrument, you will be filling some adsorbents like silica gel, etc. You have been pouring the chemicals. So silica gel, the adsorbent is a stationary phase. Your chemical will be your mobile phase. It will be moving down drop by drop. Some absorption may take place, like that in water filtration method. In water doctors and aquaguards, we have some activated carbon in a stationary manner, and we pass water into it. Your water is a mobile phase, and the adsorbent is a stable phase. Some absorption may take place. This type of simple method is chromatography. So, but here it is an advanced instrument, high performance liquid chromatography. It is an improved form of column chromatography. Instead of the solvent being to allow the drip by drip gravity like a bin burette, it has been the solvent is forced under high pressure. So it takes much faster, moves at a faster rate. Here the separation of samples, we inject some the samples depending upon its different types of elements or compounds, it has been separated. So we have two different phases, one is mobile phase and stationary phase. This mobile phase will totally separate these chemicals, so and we will get a complete separation, and even mass can be studied by this method. So this is a express solvent. HPLC pump is here. It is being injected. Sample is injected from here. So the solvent has been injected, both combined together and passes through the HPLC column. Here the separation may take place. The separation will detect the things and will get to a detector and we will get a graph. So here we can identify the waste materials are collected here. So there are two types. Normal phase HPLC uses a polar stationary phase. There are several types, not only two. Normal phase, we use a polar stationary phase and a non-polar mobile phase. In a reverse phase, non-polar nature, mobile phase will be polar, and a mixture of water and methanol can be used. In size exclusive HPLC, so depending upon the pore size, molecular size, we can use that. In ion exchange, stationary phase is ionically charged on the surface. So instrument, the solvent reservoir is there. Solvent is a mobile phase here, which will be in a reservoir, and it is passed. Inside there is a pump. The pump which aspirates the mobile phase from the solvent reservoir and from the sample. It takes under the pressure of 42,000 kilopascals, so about 6,000 psi. Then the sample injector. The injector can be a single injection or automated injection. The injector of HPLC systems has been provided with the range of 0.1 to 100 milliliters of volume can be passed inside under high pressure. There is a column. The column is 50 to 300 millimeter long and having a diameter of 2 to 5 mm, very small, and is commonly filled with the stationary phase of particle size 3 to 10 micrometers. So the columns with the internal diameter of small one, we have some microbores, so these chemicals will passes into the column. So separation may take place according to their mobility. So detector detects at the end of the column of the analyte, and based on this we'll get the signals in the detector. The detector charts records it and processes. The computer integrates the responses and give it in a plot. So with this we can identify the different types of chemicals present, even the mass can be also be identified here. So what are the applications? The pharmaceutical application, yes. Drug stability. We can pause the drug. When the drugs passes into a mobile phase, what happens? The stability of the drugs can identified. When a tablet dissolutes in a pharmaceutical dosage, how much separation can be measured? Pharmaceutical quality. Just dissolve the medicine and inject into it with certain concentration. It will split up into different compounds. So what are the things which is present in a tablet or a chemical or water can be find out. Even water, our water may contain pesticides or some organic chemicals. Just take the water and inject it. It will separate it and it will give some idea regarding the chemicals present there. Environmental application, yes, drinking water analysis, biomonitoring of pollutants. In forensic biological samples, textile dyes, steroids in bloods can be determined. So the main thing is we are pausing the solvent along with the sample. It separates different compounds present in the sample and it gives some analysis. Even food, the flavor of food, juice, polycyclic compounds, vegetable preservative analysis, a lot of wide application of HPLC, very very important. For clinical tests, urine analysis, antibiotic analysis, yes, all the things can be found. So wide range of application is here. So thank you. We'll meet the next class.